Yes, the computer in your daily life, actually, chapter number one or topic number one has been terminated. Uh, yes. Let's get started with the second unit, which is the CPU components. We are going to study the system unit, which is the processing and the main, let's say, central processing unit. Yes. Um, so let's get into details, and we start with the objectives of this unit. Mainly, we are going to list six of the main objectives we are going to go through. We are going to understand the first thing. We're going to understand the representation of the data inside the system unit, because there have to be an understandable data given to the central processing unit in order to be able to process and provide us information. We defined data and information last unit, and from an unstructured data, which is the data, to a structured data, which is the information, there will be a processes to be done. Those process capabilities, they have to be based on data that can be understood by whom? By the machine. We see the sort of the data that the machine goes after. We'll see the main functionalities of the very famous hardware available in the central processing unit. Functions, what they are doing, how they are acting, how they are functioning, so on. Some peripherals, input-output devices, as hardware also we are going to go through. We'll the same as we discussed here. We are going to understand how the central processing unit actually process instructions coming or commands coming from software applications, or even from the system application, or system applications in plural. Um, Actually, how to speed up, how to make the computer act faster, how to help the computer be more fast. And finally, not least, we are going to see some perspectives for the upcoming, let's say, generations of the computers. We are in the fifth. We are utilizing and we are living with the fifth generation of the computers that the humanity has invented. But future would come with a new, let's say, secrets, maybe technological secrets. So let's keep going on. An overview of this objective, it is exactly that we are going to visualize the data inside this central processing unit, how it looks like. What are the main functionalities of the hardware equipment available inside the CPU, the central processing unit. CPU stands for central processing unit. And also we are going to identify uh, capabilities or actions we can do in order to ameliorate the capabilities of the computer to act fast and to solve problematic computational tasks faster. Good. Let's get started. So that was the interview. Sorry, the overview of the full class upon this unit. Let's get started with the representation, how the computer sees the data. Now, actually, to make you understand what does it mean to represent the data inside the central processing unit, let me ask you a question. And now, if now when I'm speaking to you, you understand me. Why? Because I'm using the English language as a medium of instruction, and this is understandable to you, and you can understand the speech. I'm using correct lexic. You understand the words. You understand the tone. Everything I say is understandable to you because it's a language that you understand. Your brain can receive and has a translation to what he receives. The same way, the computer, the CPU, the central processing unit, has to receive something in input that he understands. If I give him something actually he cannot understand, he will not do. If I speak to you in Chinese, if I'm going to speak to you in French, will you be able to understand? According to my knowledge about you, you'll not be able to do. Why? Because this is a new language to you. This is something that you cannot understand. This is what we mean by the data representation into the CPU. So this is actually defining what is the data representation. Regarding the data itself, what is it? Mainly, we talk about two statuses that the statuses that the computer can understand only, usually, and once for all. which is the true false, the on off, the 0 1, the yes, we said the true false, the valid invalid. Those are two states that the computer can act with uniquely. To complete all the digital tasks, the computer would go only with those two statuses. Whatever the task is, whatever the command coming from the software or system application is, or whatever the request to be done, he can act only based on two statuses, either on or off, either true or false, either 0 or 1. What does it mean? Means the totality of the data inside a computer would be represented with two status, either 0 or 1, which are numerical values, either the number 0 or the number 1, which are at the end of the day, those are the two unique data that the computer can see or understand when we as users we are presenting the data to the computer. When we are submitting or inputting data to computer, the processor, the central processing unit, can see only zeros and ones. That's it. If we write numbers from 0 to 9, the numbers has to be changed to 0 and 1s only. Otherwise, you will not be able to process. If I type text like this slide content here, the computer, the processing unit, has to receive this data as zeros and ones. Otherwise, he will not be able to process and display everything. This picture graph here, we are visualizing and output this graph. And we are able to see because the processor is doing that for us. But in input, to receive it and process and display it like this, he has to process only 0 and 1s, which are the origin of this image, translated to a computer understandable language. Conclusion: every data, whatever the data is, or whatever the source is, presented into the CPU, has to be translated into a language that the computer understands, and the computer language, or what the computer understands, is only the zeros and ones, which are the state of true or false or on or off. And based on those givens, which are the list of zeros and ones, the computer will do the processing capability, or he will do his processing task, and he will provide us an output. As per example, to see this slide here, the computer had a long computational task based on zeros and ones, and he displayed to us this slide here with the background pictures on this text and the borders and everything. It's all based on the usage of the zeros and ones only and uniquely. Any questions?
No, mister.
That's great. We continue. So we said that the language that the computer understands is only the zeros and ones. The computer, can we input a text file, for example, a doc file, Word file, MS Word file, or any other text based editor or text based file? Yes, we can. Can we insert a video to the computer and we save it or display it? Yes, we can. Video. Can we insert a graph, a very big picture with a high resolution based actually property picture? Yes, we can. Whatever the media we try to insert to the computer, it would be inserted, and it would be translated to zeros and ones. That's great. So when we put when we input data to the computer based on, and the computer translates it to zeros and ones, he do his processing tasks. This data has to be measured. Would be the computer, can we give any data for any size? What does mean size here? We have to understand. The meaning is that the computer has to have a space to put the data in order to process it, which is a memory. And the memory has to measure the data with some unit. We talk about the bit, and then after we talk about the byte. The bit is the smallest data unit to use to measure the data in memory. What is the memory? The memory I just passed through in a very abstract way. at a glance, which is actually a space to put the computer uses to put the data in order to process it. It's a place the computer saves the data in order to, there are types, there are models, in order to be able to finalize his processing tasks. To measure the data in the memory, there are units. The smallest unit to use is the bit, which are mainly either 0 or 1. This is a bit, this is a bit. 0 and 1, they are 2 bits, and so on. See here, see the graph here, see the graph here. We are seeing list of 8 bits. 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits, they constitute 1 byte. 1 byte is 8 bits. So, at the end of the day, now we are recognizing two main, very basic and very popular and very let's say, um, uh, constructive data units, which are the bit and the byte. Every data in the memory used by a computer for processing whatever, they are measured with bits and bytes mainly. There are other units, so we know that the bit is either a 0 or a 1. And a series of 8 bits constitutes a byte, 1 byte. 8 bits, 1 byte. 16 bits, 2 bytes. Let's say 32 bits, 4 bytes, and so on. There are other data units that we can go through, which are kilobyte, megabyte, gigabyte, terabyte, petabyte, and so on. So those data units, they are not like the transition from the bit to the byte. They are 2 power 10 each from step to another. 2 power 10 each step we go. Let me explain more. A bit constitutes actually is the smallest unit. 1 byte constitutes 8 bits. Okay, from now 1000 bytes is 1 kilobyte. See the unit here. Actually, this is in an abstract way. Technically, it's 1024. It's 2 power. Actually, when we see, I'm going to write something else. I'm going to write something else here. 2 power. Let's say 2 power 10 volts. The number is, the result is 2000 is 1024. 1024 is 1 kilobyte. 1 kilobyte. 1024 what? Bytes. 1024 bytes, volts, 1 kilobyte. This is technically represented. I need you to memorize this also. But to make it easier for us, so 1000 bytes is 1 kilobyte to memorize. 1000 kilobytes, 1000 kilobytes, then we pass to 1000 KB equals 1 what? MB. Then 1000, let's say 1000, yes, megabyte, mega MB, yes, equals what? 1 gigabyte. And so on. We go on like something like that. So ضرب 1000, we multiply by 1000. This is actually an abstract. This is at a glance only. But remember, we go from one unit to another is by multiplying 2 power 10 by 2 power 10 by 2 power 10 by 1024. We find 1 to the power 10 actually multiplied by 1 byte. We find 1 kilobyte. 2 power 10 multiplied by 1 kilobyte. We find 1 megabyte. 2 power 10 multiplied by 1 megabyte, we find 1 gigabyte, and so on. This is technically how it goes. But at a glance, we go 1000 kilobyte is 1 megabyte, 1000 megabyte is 1 gigabyte, 1000 gigabyte is 1 terabyte, 1000 gigabyte is 1 terabyte, and so on. We go from a unit to another this way. Any questions?
No, Mister.
Is it clear for everybody, please?
No, Mr. Thank you.
Khalifa, is it clear?
Yes, sir.
Yes. Great. So we pass. I'm gonna delete this one. I'm gonna pass. Actually, it's a matter of understanding only. Here, you just need to understand the concept. It's not a context that we are going to do in to go for deep technical details. No, no, no. It's enough here. It's a matter of understanding. You know now the computer how he sees the data, and how it looks like when we move from a unit to another, and how the data is measured inside the memory. Full stop. Deep technicalities, this is actually to be presented to the computer students, not to you as business students. So let's go and let's proceed to the next step. The representation, actually, still we are talking about the data, how it is represented inside the memory. Binary, we said that it is the main unit. Zeros and ones, and the off and off, true and on and off, true and false, they are the data to be represented inside the computer. But it's not the unique data to be seen inside the memory. What does this mean? What does this mean? This means that, listen carefully, please. Listen carefully, please. The speech I'm speaking to you now, the speech now I'm speaking to you, I'm explaining to you, it is coming to you at the end of the network, wherever you are, and it is being spread through the network. So it has been inputted to the computer, isn't it? Does the computer understand the speech, whether it is in English or in Arabic or whatever? No, he does not. What does this mean? It means there is a data presentation to be actually presented and then after translated. Because if I speak a text, it's not like when I give numbers. It's not like when I give a picture and so on. Based on this diversification of data to be inputted to the computer, we see databases to make the translation from a given data, let's say, to another. Still, we are talking about data only. We are not talking about information. Still, note the words we are utilizing. We are using the word data here. The conversion systems from an input data to another, we present from them, the first one is the binary numbering system. What is this? This is a system that translates every data, let's say every data, we can generalize to a system based on zeros and ones. Binary system will translate an input data or an input data to zeros and ones only, a series of zeros and ones, 1 1 1 0 0 0 1 0 1, and so on. This is a binary numbering system. That's what he does. That's what this binary system do. It translates whatever the data is, picture, video, text, audio, slide like this, or whatever. It translates them into series of zeros and ones. Binary numbering system is not unique. Decimal numbering system is another system also. The decimal numbering system is another context. But this decimal numbering system, it is a subcategory of this binary numbers. What does it mean? It means it takes the numbers from 0 to 9. It takes the numbers from 0 to 9 and translates them back to binary numbers, and vice versa also. Actually, to translate from 0 9 to 1 and 0, this is an input. But in output from the binary based data to decimal based data, also it is a decimal numbering system to act. Means if we give, for example, I give you the following number. See, I'm going to type something. Sorry. I'm going to type something. Okay. For example, I'm going to type 0010. Okay. See what I typed right now. 0010. What is this? This is something the computer understands. This is the computer something that the computer understands. But for us to understand, I give you the number 2. See, I wrote 2. For me and you, if I type 2 only, it is understandable, something we can understand. The computer does not understand. The computer understands this thing. So in binary system 0010, this is the representation of the 2 in binary system. This is in decimal system 2. This is in binary system. To translate in input, me, I type 2, the computer sees 0010. In output, the computer process 0010 and display in output 2. Those conversions, those behavior here, those behaviors in plural, actually to be done by the central processing unit. Now, in conclusion, just to bring your attention and to make you understand more what I was explaining, let me delete this thing. Actually, just I highlight this one and delete later. The representation of the data has to be in binary, has to be measured and put in memory and measured, yes, using data units. Then after, there are conversion systems to act from let's say a data type to another, from a data to another. We given the example of the binary data and the decimal data here. Binary means based on the zeros and ones only. Binary 2 means either 0 or 1, 0 or 1. decimal العشرية، الأرقام العشرية ولكن تنتهي في التسعة. الأرقام العشرية آخر رقم هو 10 minus 1، 9. الباينري الثنائية آخر رقم هو 2 minus 1 اللي هو 1. سهل تتذكروها بسهولة. Good. We pass now to unless you have any questions, we pass to the next topic. Any questions here first?
No, Mister.
And the others? Maram, any questions, Maram? I don't know. Great. Maram, are you here? Balqis, no? Maram, are you here?
Yes, Mister.
Any questions, Maram? Any سؤال, any استفسار?
No, Mister. Thank you.
Okay. We continue, so. Still in the same context. Actually, this is a recap. This is a recapitulation of what we were explaining. For example, see the number here. I'm going to just go very briefly and very quick. See the number 7,216 here, the number in decimal. This is in decimal. Why in decimal? Because the 7 is more than 1, sorry, bigger than 1. 2 is bigger than 1. 6 is bigger than 1. So it cannot be in the binary system. 7,216. It cannot be in the binary system. And we saw so far إلى حد الآن, we saw only two, let's say, conversion systems or two data representation systems, which are the binary and the decimal. So this one can be only in decimal because the 7 is أقل من 9, أقل يساوي عن 9. 6 is less or equal to 9 also. So it is in decimal system. We segregate them in order to make the computer understands what is this. The computer will see them one by one. He will not understand this is the full number 7,216. No, he will see them 6, 1, 2, 7, and so on. Something like that. The 7 would be represented and matched with a decimal number. The 2 would be matched with a decimal number. The 1 would be matched with a decimal number. The 6 would be matched with a decimal number, and so on. This is actually what the computer will do. He will match each with the respective decimal number and will make the calculation. No more, no less. You may memorize this number, but this is actually title of example only. What you have to memorize is that a human understandable language has to be matched with a respective, each character or each letter, actually, each character or each number, sorry, has to be matched with a respective decimal representation. Mainly we talk 10 power something, 10 power something, 10 power something. As we remember, as we explained just earlier today, technically we are representing either 2 power something, or in this example, decimal base, we talk about 10 power, binary base, like here, 2 power, decimal system, we talk about 10 power. Okay, still we go, we talk about the representation of the data into the computer. Here we are talking exactly about the conversion, not only the representation, but here in this view, we are talking about the conversion, or let's say the conversion, yes, absolutely. There are standards and standardization units that they go after making the conversions unified for all, mainly all the commercial international business machines, computers, or the computational computer-based actually, or the processing based machines, computers, mobiles, all the kinds of the machines. We see in front of us two very famous standardized, let's say, systems that they do the conversion of the, let's say, human-based language into a computer-based language. The ASCII and the CDIC. Actually, the ASCII is both of them. This one and this one, they are two standards. Two of them they are utilized by the international business machines producers. Whatever, any computer you buy, he's either following this standard or this standard. And mainly those are two soft configurations, means a computer might be reconfigured to either follow this or this. Yes, for example, your computer, you bought a computer that follows the American standardization, let's say, mechanism. So he's going to follow this ASCII. Great. No, no, no. I'm going to move to Europe. I'm going to live in Europe. I'm going to move to France, for example. And my computer, I want him to be, I'm going to use the computer in a European, let's say, organization or something like that. So I need to change the conversion system, not the ASCII. I'm going to use this one. Can I? Yeah, absolutely. We can, because it's a matter of logical configuration inside the computer, no more, no less. It's not actually a secret here. It's not a mystery that has to be seen by you as a hidden function. No, no, no. See here. See in this graph. See in this graph. If I tell you to read those characters, you'll be able to read. And also, if I ask you to read those numbers, you'll be able to read. But if I ask you the following, will you understand what does those characters, what do they vault? What do they have as meaning? Yes. They are letters or numbers from the decimal system or decimal base, or from the alphabetical, or from the symbols. They have a meaning in our heads, in our memories. But those things, they are numbers, but they are meaningless. 00110000. This is a computer language. This is a computer language. It is the role of the standardization, let's say, mechanism to act, to translate what the character we understand into something that the computer understands. 0 is represented like this, using the ASCII code. 1 is represented like this in the ASCII code. 2 is represented like this in the ASCII code. F is represented like this in the ASCII code. Hash is represented like this in the ASCII code, and so on. They are not unique. Every and each single value may presented as a human-based, let's say, language, it has to have a translation using the ASCII code. The same way, if it is followed by the CDIC, mainly the ASCII code is the very famous one, because it's an easier way to make the computer act more fast, and for us as humans to understand, and for the developers to be utilized. So for all purposes and aspects, the ASCII is more trusted somehow. Any questions, please? Any questions?
No, Mr.
That's great. Khalifa, I have a question to you, Khalifa. If I want to create, for example, something in Arabic inside the computer, I'm going to do something in Arabic. I'm going to do something in the computer. The full computer is not manufactured by Arab people, unfortunately. This is unfortunate, absolutely. All the tasks to be done inside the computer, they are done with foreign languages when we compare them to the Arabic basic language. The same thing, actually, if we look to the extreme Orient countries, they are using strange symbols. Still, the computer does not understand. They are not the native. They are not the native characters that the computer understands. But they are having meaning for humans. Those things here, and even the Arabic letters, they are having meaning for us as Arab people. Yet, for the computer, they do not have any value. They do not have any representation. Thus, and uniquely for this purpose only, and uniquely because of this reason only, the unique code has been imposed. Still, we are talking about the data representation into the computer. Talking in Arabic, writing in Arabic, reading in Arabic, displaying some text in Arabic, or writing in Chinese or in Greek or whatever you are seeing here. Computer does not have any capability to understand that. Computer does mean either you are displaying or writing on the web or on a text editor or wherever you are. Even speaking, even speech. It would not have any translation. The computer will stuck. He will not do anything. He will not act. To make the computer understand those strange symbols and those strange inputs, the Unicode has been set and brought into action. What does this mean? What does this mean? We were talking about the data representation, data units, memory. We talked about the conversion systems, the binary decimal, and then after the ASCII and the ABCDIC. What is this Unicode again? It's still here, yeah, absolutely. Because remember, we did not talk about the strange characters here. We did not talk about the strange characters here. We did not. All the conceptions and what has been conceived already, it is based on English only. But what we are seeing now is something new completely. What is this box here? This is something in Chinese. Can you understand? Only Chinese people will understand this thing. Only who speaks Chinese, you will understand this this thing. What is it? The computer has to process this. The smart computer, to be said that it is smart and capable to do, he has to process this, and he has to give an understanding to this thing. For example, Unicode will be in action. Unicode will be in action. Actually, it is a common character representation that stands on 32 bits representation, no more. It is universal still standardization, let's say, conversion system. It's a conversion system that goes after displaying and manipulating old languages mainly at the beginning, because later on there are versions of this Unicode. There is no unique Unicode. It's not the unique conversion system, and it is replacing the ASCII in some let's say text coding systems. Means it acts instead of the ASCII, which we just explained here, in some text coding systems. Why? Because it does the translation. Here, this one does not have a representation in ASCII. This box here, this Chinese letter, but the Unicode has a translation to this box. So this thing would be following the ASCII, the Unicode, not the ASCII code. Any questions? Any questions, please? Do we have any questions here at this point?
No, Mr.
That's great. Now we come to actually a bulb of data. We are talking about bulb of data means we are not talking text and the speech. They are actually simple textual, or let's say speech representation, graphics and videos, or maybe even the audio. They have one property, which is the memory size a little bit more bigger than the text representation. If I speak a phrase, for example, I tell, "Hello guys, how are you?" 4 words. "Hello guys, how are you?" 5 words only. If I write them in memory, for example, they measure 2 bytes or 100 bytes or something like that. But if I give the same text but in speech, the memory size will be different. So we talk about bulb of data. Bulb of data. Let me write the word. Bulb of data. It's a sort of data type to be represented in the data, no more no less. We'll come to this context. Graphic first property to bring it to your attention is that your computer does not understand nothing related to the word graphics. When we say that I'm going to insert a picture or save a picture inside the computer, or I'm going to pass as input a picture to the computer can understand nothing from the word graphic or picture or photo. Nothing, completely nothing, because the computer does not remember, does not understand only. He understands only zeros and ones. فقط 0 and 1, 0 and 1, 0 and 1, nothing but the 0 and 1. You give him a graph, a very beautiful graph, like this one here, for example, here, this background here, this tree. He does not understand. He does not bother even to understand it, because this is sort of data for him, and it has to be represented with some, let's say, properties and characteristics to make the computer understand and display this thing in final view as a picture, as a graph, or as whatever, bitmap. What are those properties and what are those characteristics? Mainly the height, width, resolution, number of pixels, and so on. There are some. What you have to memorize is that there are characteristics and properties to give with this file or with this data to make the computer understand what is it. Here we see some. Mainly, a picture has a grid view. The computer will understand that there is a sort of shape to be displayed because of the property grid. Then after it is displayed, sorry, it is still passed as group of pixels, which are resolution, which are at the end of the day height and width, and so on. For the property, for the specific type, the bitmap actually typed images, they are having, let's say, a range of colors to be utilized to display the images because there are models of displaying the input, and I'm talking about the input only and the display also. There are models of displaying the images or the graphs into the processor. For the category of the bitmaps, he is having a range of colors to understand: blue, white, yellow, red, and so on. There is a range of colors to be passed to the computer. What does this mean, range of colors? He does not understand the range of color. No, he understands, because this is a property, and this property is represented by zeros and ones, and there are measurements for the color. Actually, either it will use the 4-bit or 8 bits or 24 bits and so on. So there are ranges because of this range, the color will be measuring a size and memory. The color itself, when you say, see, this here, this leaf, this red leaf here, it is a little bit pink. It has a size and memory. The color itself, it has a size. If you are utilizing a bitmap, for example, it is 4 bits only. For example, if you are utilizing something different than bitmap, JPEG or GIF or whatever, maybe it will measure, for example, 64 bits. So there is a point of view behind of which we choose how we represent the data. At this point, I come to an end for today's class. So if you have any questions, please raise them up. Otherwise, please, if you hear your name, please type yes. You don't type yes, you are absent. I'll stop recording and I'll ask you to now you type your name. Type yes, please, if you hear your name.